Alright, let's see if we can't make any other connections between changing the numbers in our function and the graph. I'm going to stick to our parent graph again, x squared, and what I'm going to do this time is I'm going to overlay a few graphs on top of it. Right now this is the graph for 1x squared. Now what I'm going to do is I'm going to add the graph 2x squared, 3x squared, and let's go a little more extreme, let's say 10x squared. Oh, I lost my parent graph. Let me just add one more here. There we go. So this outermost one is where we started, our parent graph, x squared, right here. And then we've got 2x squared, and then the inside, 10x squared. Notice what happens with our graph. The vertex and our axis of symmetry is the same, but notice how the parabola has narrowed down. Let's try this again, but with, let's say, negatives. Okay, here's negative x squared, upside down facing parabola. But let's change things. Let's make it negative 5x squared. Oops, negative, there we go. Okay, and one more. Let's do negative 15x squared. All right, notice what happens. Here on the outside is negative x squared, our negative parent graph. Negative 5x squared is right there, and then innermost negative 15x squared. And once again, the graph became more narrow. And the negative really had nothing to do with it. The negative was just telling us it opens up upside down. It's that changing of the number after the negative from 1 to 5 to 15 that created this narrowing. And so here's what we want to copy down. Turns out that if you take the absolute value of a, because really that negative is not about this part. Negative tells us whether it opens up or down. It turns out the larger you make the value of the absolute value a, the narrower the parabola gets. And the smaller you make the value of absolute value a, the wider the parabola gets. And so again, if we can compare different functions, we can see which ones will be more narrow, which ones will be wider. So for example, I can take a look at this, and I can do this problem without actually graphing it. Order these graphs from widest to narrowest. Now, when you see these instructions initially, you might think, oh, well, I'm supposed to order things. But we don't have to. What we can do is this. We can look at this first one and take the absolute value of a, in this case, the invisible one. So absolute value of 1 is 1. This one, take the absolute value of a, which is a half, and then absolute value of a here, which is negative 2, but absolute value of negative 2 is 2. So 1, a half, and 2. So as far as the widest one, if I go back to my definitions, the smaller you make absolute value a, the wider the parabola gets. What I want to do is I want to look for the smallest value here. Okay, so as you copy these down, recopy them a second time where, let's see, this one is in front. Because according to its absolute value of a, this will turn out to be the widest graph of the bunch. The next as we narrow things down, the one that's second place in terms of width would be this one. It has an absolute value of 1, and then this would be third. This would be the most narrow graph with absolute value of 2. So even without graphing, knowing these rules here, I can figure out which ones are the more narrow parabolas versus the wider parabolas and order things accordingly.